Hey guys, I'm so sorry the video was cut in here. I don't know what is the issues, but let me continue from here. So I just stayed in here and all right, this is example one. We sat here. Let's start with the expression A equals B and C equals D. And I just already spoke about that. Again, our conversation here, we didn't use any nots or nothing else, the Morgan's laws. So in here, we will say, again, our expression A equals B and C equals D is equivalent to two knots. So if you apply here two knots, like not, like if you say not A equals to B, and like it will be a not equals to b, and if you say not a, so if a not equals to b, if not a not equals to b, it will be a equals to b, again same. If you say not and, it will be or in this case, right? And so not and will be or, and if you apply again not or, because we will put not in here, and we will apply also for here, and also will apply for here. So in this case, so what will be that? Not a equals to b and not c equals to d, the last case. So it will make it not, it will be same in here, a not equals to b. It's here a not equals to b, right? And c is not equals b, and c not equals to d in this case, right? And it's here. So now if not A not equals to B or C not equals to D. Let's apply for all of them. Not A equals to B, it will be A equals to B. Not or will be and. In this case, A equals to B and. If not C equals to D, then C equals to D. So it will be A equals to B and C equals to D. It is same like before this case. Bam, it's here. It is same when we apply this knots, so Morgan's laws, it will be same. To recap, we first made our expression longer so that we could apply the Morgan's laws. The final result in this case is more complex and therefore maybe not something you would actually do. But the next example will show where adding knots might be especially useful. Example 3, let's look at it. What will happen here? Consider these expressions. A is greater than or equals to B and A not equals to B. I can see it. What does it mean, A is greater than or equals. Let's say that it will go. So exactly is that A greater than B. So can you see that? All right. A is greater than B because this equals and not equals will pass to each other, will drop each other, and it will be just A greater than B. So let's look. A greater than or equals to B and A not equals to B. Let's say in here is equivalent to not equal, like not less. So not A less than B, then A has to be greater than or equals to B. This one equals to that one. All right. So this one equals that one. All right. Yeah, that one. A greater than or equals to B, not A less than B. It will be that. Or if you say A less than or equals to B, it will be not A greater than B. So in this case, it's equivalent to not less and A not equals to B. It will be same. All right. It's equivalent not equals. We're applying all of them right now. Not A less than B and not A, if we put here another not, it will be not A equals to B, it will be like A not equals to B. So let's look in here. Let's tag them, all of them, into parentheses and apply this not for all. Not and not A equal less than B. So not and will be or, not will be not A equals to not, like A not equals to B. And after that, if we apply not A equals to B, it will be same. So let's look at not A less than B, or in this case, A equals to B. Not will go. So what does mean? We can say not A less than or equals to B. In this case, we can say A is greater than B. It's equivalent to not greater. So what we did, do you understand? We just changed it to that. So it's A greater than or equals to B, and A not equals to B equals to A greater than B. So because I told you equals and not equals will pass to each other, will drop each other, and just it will stay there, A greater than B. All right, that's all. This says A is either greater than B or equal to B, and A is not equal to B. This means what A can only be greater than B, since it cannot be equal to B, A greater than B. That's exactly our simplified equivalence. Check your understanding. Consider this pseudocode. Consider the pseudocode. User type is power and age is less than or equals to 10, which is equivalent to this one. User type is power. User type is not equals to power. If you apply here not, again it will be user type is equals to power. I told you user type is not equals to power, not equals. If you apply this not to inside it, it will be equals to power. Not or will be and in this case, right? And less than or equals 10, if you apply not for this one, if not age greater than 10, it has to be less than or equals to 10. Yeah, so it has to be greater than 10. So in this case, it will be true, not or will be and A is our true answer. So I don't want to look them. So you can do it later, all right, for yourself. So also we have here this one. You can say two. Not user type is not equals to power. Not user types equals to power. It's equals to power. Not and will be or. Okay. Here we are looking for and. Not or will be not or will be and. In here not and will be or. In here not or will be and. User type is not equals. Okay, it will be equals, but in here this is wrong. So guys, it's all. This is part 1, like 3.1. This is last lesson. So which is I told you, I just the video was cutted. You can continue from here. So from this place, yeah, right, from here, this is part, let's say part 2.1. All right, 2.1. Logical equivalence. Logical equivalence. All right, logical equivalence part 2.1. This one is okay. This is end of the lesson. It's all finished. Thank you very much. Have a good time. All right. So also, I would like to tell you one more things. We will continue for the procedures. Next lesson will be procedures. Defining a procedure will be subtopic of the procedures. You will learn everything about functions and others. Just be there, and everything you will learn with me. Okay. Parameters, name, function name, and all. Have a good time, guys. Thank you very much. See you in another lesson. Right, let's come to here. Right, it's our point. So have a really good time. Bye bye.